Two high school girls attach ropes to a cart so that they can pull it together. If one exerts a force of 92 newtons, north 12 degrees west, and the other a force of 56 newtons, north 76 degrees west, what is the net force on the cart? Use the vector components method. So, what we're going to do, we're going to start by drawing it out. So if this is our coordinate system, this is north, and this is west. So, the first vector was in a direction of north of 12 degrees to the west, and that has a value of 92 newtons. The second one has a direction of north 76 degrees west with a force of 56 newtons. Now, what we need to do to calculate the net force is split each of these vectors into their x parts and their y parts. So, the first vector is 92 with 12 degrees, can make it a right triangle, where we're looking for this, the x part, and this, the y part. To solve for that, we can plug in that, because this is the hypotenuse, 92 times the sine of theta will equal the force in the x direction. So, with some numbers, we figure out that 19.1 newtons equals x. Similarly, we go 92 times the cosine of theta, cosine, we'll find our y part, which is 89, it is 90 newtons. Perfect. Now, if we do other vector, this one's a value of 56 newtons with an angle of 76. This is, of course, a right angle. This is your x part, and this is your y part. So, the same way, if you go 56 times the sine theta will equal your x, and so your x is equal to 54 newtons. And if you go 56 times the cosine of theta, get your y, which is 13 newtons. Equals your y. Sorry, that should be 14 newtons. This is because when you put in theta, you're actually putting in 76. That's your theta. And same way in the other problem, where you put 76, whoops, sorry, B12. That's your theta. Now, what we need to do is add the parts together. So if we start off with the x part, I should also mention that both the x parts are going west and both the y parts are going north, so there is no problem with that. We can just add them straight. So the x part of the first one was 19.1 newtons, plus the x bar of the second one was 54 newtons, which will get you 73.1 newtons. In the y part, we can also add, I should say this is 73.1 newtons in the westerly direction. In the y part, we add up, we have 90 newtons from one vector, plus another 14 newtons, and that adds up to 104 newtons north. Now what we can do is sum them together in a new vector. This will be a resultant vector. So we take the x part, this is 73.1, and your y part, tip to tail, 104. Now we are looking for the net force. We need to find both the magnitude and the direction. So we're looking for x, and we're also looking for theta. Now, to get that, you can use the Pythagorean theorem, where x here will equal square root of 73.1 squared plus 104 squared, which will give you a value of 127 newtons. And now you can use the tan of theta equals opposite over adjacent, 104 over 73.1, and so theta equals 55 degrees, and this is west to north, so it's actually west 55 degrees north. And to keep it consistent with our original, we're going to say that it is 127 newtons north, 35 degrees west.